Okay, the afternoon is short and Git is long, so let's make a start. Hopefully everyone is here for the intermediate Git or the course entitled slightly alternatively, Git for Scientific Software Development, which should give you a little clue whilst we will maybe cover some more advanced Git topics today. This is also particularly about how you can use Git as part of your workflow, sort of to write effective software, do effective science, and go and save the world. So this is by myself, Jack Atkinson, and also Adi Bankoli, who's at the back, and will give you a wave. If you do have much like the RSE skills session this morning, this is designed to be interactive, so please stick a hand up and ask any questions. And hopefully some of the other friendly neighborhood RSEs will also come around and give you a hand should there be that many problems, which hopefully there won't be. So just as a sort of starting point, I guess, if people put their hands up, who has used Git before? Which is hopefully correct. Otherwise, I would suggest you go upstairs. Who used Git this year? This week? On a daily basis? On an hourly basis? Super. So that sounds about right. So before we get too far into things, I'm kind of assuming if you're sat here that you are happy with using git clone, happy with using git add, git commit, and git push to do things. If not, you might find yourself having a bit of an easier ride upstairs. So there you are. That was your chance. So the slides and materials for this, you can follow along the slides in your own time at the link here. Sadly, this is a little bit small, but hopefully if you find the slides, then you come along and it'll be bigger. And then all the materials are in either the GitHub or the GitLab repo. Don't worry too much about that for now, because actually obtaining these materials will be one of the first exercises as we go through. Does anyone want that sitting there any longer to get the link? Okay. Again, the same thing as this morning going through. So I thought I'd start a little bit talking about Git itself. This will recap just to make sure we're all on the same level. So if you do know everything, please bear with us. So what is Git? Git is a version control system. Hopefully you're all familiar with that. And you have some idea of what we mean by version control system, or at least think you do. The main thing about it is that as you work on a set of files, a code base, something else, not necessarily code, it could be anything, your thesis. As you make changes to these files over time, Git provides you with a way of tracking these changes in sort of a timeline manner, and also allowing you to kind of roll backwards and forwards to undo things, recover things, etc., etc. A small trivia, I guess, is that it was created by Linus Torvalds, who is also the man who invented, can we say that, or wrote the original Linux kernel. And indeed, it was came about as he was working on this and trying to find a way to track all of this work he was doing. It will be left as an exercise for the reader to go and find why he chose to name it Git, amongst other things. And the image we've got here is sort of just to illustrate that whilst many people might have come across this as sort of, you do some work, you add some files, you commit and push them up, there's actually sort of a whole rabbit hole of other things you can do with Git to enhance your productivity and workflow. And it's some of that we want to look at today. So I'm going to go through this because I'm hoping, given that no one complained in the session this morning, everyone's got Git on their computer. And everyone has got a GitHub account. So in terms of how Git works, there's a mental model and then there's the actual model. And as with many things in science, climate science, wider science, it's often useful to have sort of this mental model to think about things around that sort of wider, more complex thing. So the mental model we usually work with is that if you do a little bit of work, maybe you add a function to a file, then if you add and commit that, Git will take that little function, those 10 lines you've added to that file, and store it as a diff, which is saying you've added 10 lines into a file in some location. And indeed, you might have seen there's the command git diff, which will show you, and we'll look at this in a moment. Diffs are then stored in what we call a tree. And the idea is that if you add some lines, commit them, they go into this tree as a commit. You do some more work, add some more lines, put them into the tree. By sort of tracking down this branch of this tree and applying all of those diffs, adding lines, removing lines one by one, we can construct this sort of past timeline of that file. And the nice thing about Git is that we don't actually need to do this in order. So if we decide we want a particular number of commits somewhere else in our code, we can just pull sort of those three, that little chunk of a branch and move it and apply it somewhere else. And as long as everything's working nicely, we'll get the specific code that we want. So I'm gonna, let's go, no, let's stick here. So when you run the git diff command in the terminal, as you've maybe seen, you get something like this. So here we're saying, looking at the git diff of some code here, my code functions.py, and you'll see something like this. So if we break this down, you'll see that it will tell you sort of these two files that appear in the diff. There's the my code functions.py before we made some changes, my code functions.py after we made the changes. And you can see that we've removed files, so removed stuff from one and added stuff to another. The next bit is that we get some information about exactly where in the file this has been done. So this will give you some indication of, I think, line numbers and sort of the chunk of lines that have been modified by this. And then underneath that, you'll see that we get some minuses in the gutter showing us what lines have been removed. So in this case, we've kind of moved this, got rid of this nested if-else clause. I think if we'd run some static analysis from this morning over this code, it would have told us that nested if-elses are not ideal if we can do something better. And indeed, we've replaced it with a single if and final else, which is sort of much cleaner code. And so the pluses then show us which lines have been added new to our code. And so in total, that then makes up the content of the git diff when we view it in the terminal. And this kind of matches that mental model we were talking about, where Git has, in this little chunk, tracked for the changes we made, lines that have come out, lines that have gone in, and then you can imagine lots of these being compiled upwards. This is not how Git actually works. Lots of people sort of talk about Git being very, very clever and storing little changes in files rather than storing your entire file. What if I told you that Git, in fact, stores your entire file every time you commit the code? It does this sort of for efficiency reasons, and then it makes sort of, does much better compression things later on down the line. But the fact that it stores the entire file is what it allows us it to be much, much quicker than, say, other version control systems like SVN, which do store just line-by-line changes and take a lot longer. So I won't go into this too much, but it's an interesting thing to read about, sort of if you're interested in that. So yeah, like I say, just to bring us all up to speed, we'll go through the sort of most basic commands. So git clone will give it a URL to a .git repository. It will pull that down, put it into a file where you want it. And so I guess we can start with the code we're working on here. And you will do this in a second. But if we copy that URL, what you might not have known is that you don't have to clone it into exactly what the name of the Git repository is. You can give it a unique directory name. So here, where we wish to clone something, if I type git clone, and if this isn't large enough, someone give a shout, please. So I might want this to be put into Git workshop. And you can see if we add that directory, it'll indeed give us Git workshop rather than the name of the repository. Okay, so git status and git add, two other very useful commands, hopefully not particularly new to anyone. So git status is just going to give us the status of the repository. So it will give us sort of that base information, what branch we're working on. This will become useful when we start talking about other branches shortly. And it'll tell us that we've got nothing to commit. So hold that thought there. Git add, if we've got new files or files that we've changed, then we can add these, which will move them into the area that says Git is now looking at this and wanting to track it's being used. So suppose I add a new text file. Oh. How do I exit Vim? So we've created a new file, and if we now run git status, you can see that it gives us a little bit more information here. So it's telling us that we've got a new file, but it's because it's a brand new file, Git isn't kind of tracking it, following it. It knows that historically we've not been making changes, so it's listed as untracked. So as we said, we can do git add myfile.txt. But maybe I've added sort of half a dozen files. Is there anything wrong with doing that? So it's not particularly descriptive. The other equivalent, I guess, is git add -a. So this will, if I do git add -a or the entire repo, it's going to git add everything it can find there. Yeah, so yeah, it's going to grab everything it can find. And whilst it's tempting to do that if we're feeling lazy, I would say never use git add -a or git add everything. Try and be specific. Hopefully after doing this course, you'll be committing things in smaller chunks anyway. Hold that thought. One thing I would do is if you do find you've got a lot of files that you've changed that that are already being tracked, you can use git add -u. And what this will do is it will add all the files that have changed, but only the ones that are being tracked. So if you do know there's lots in there and you want to add stuff that's already in Git, that can be a handy shorthand. But again, give it a bit of thought about whether you want to break this down a bit smaller or not. So in conclusion, I would encourage you to try and be more specific when you do this. And you'll find that having done that, now this is no longer an untracked file, but it's actually tracked, it's moved into green, and it's ready to be committed. And indeed, the next command is git commit, which hopefully people are, again, familiar with. We can do git commit -m and give it a little message to say something. So there we go. So we give it a little commit message, which when we're sort of tracking back through all of these little diffs that we've been doing, it allows us to read it and understand sensibly what was done. So finally, I think the last command I wanted to talk about was git push. So here we do git push. And here the two arguments that go into this, first of all, are the name of the remote place we're pushing to. So usually this will be origin, which is kind of the first thing that's set up by default when you clone a repository. But it may be that you want to work with sort of code on two systems. Maybe you've got the base code, but you've also got your fork of the code and you want to send things to different places. If that is the case, you can do that by specifying different remotes here. And then finally, we give it the name of the branch that we want to push to. And again, we'll be coming back to that shortly. So hopefully this does a few things. You can see, as I said, there's a little bit of sensible stuff that Git does, actually trying to compress stuff. And then it will send it up to the repo, in which if we now refresh, we can see we've got this new commit message and this myfile.txt has appeared. Hopefully, none of this should be particularly new to anyone. If it is, stick a hand up. But the last thing I sort of wanted to talk about is the Git Atlas, as it was. So we'll be talking throughout the course about a few different regions of space in Git, and I'm hoping this is now fixed. If not, we might have to wait. But there's a few things. So the workspace is the area of Git in which we do our work. So you can think of this as kind of just that local folder that you cloned everything into. And you can create files in here, you can delete files in here, you can change files in here, you can do whatever you want. This is all the workspace. Git sort of hasn't done anything to interact with that yet. The second thing we talk about is the staging area or the index. So this is where files go once we git add them. And you'll find that this is, when we use git add, we've said, I've done some work on this file. I now want to put it into the staging area, ready to be committed as some piece of work. And indeed, if we go back to sort of myfile.txt and add a bit more to that, we could add that into the staging area. We might then do a little bit more work. But if we've not added that, you'll see that the changes that we did specifically add do still exist in the staging area as we requested them. And any work we've done subsequently is still listed as untracked. So this can be useful if you want to make changes to a file, combine it with something else for a commit, but not include later changes in that same commit. So yeah, you can think of sort of stage changes as being separate within the file to changes that you put in your workspace. Finally, the local repo is the repo that's on your computer. The remote repo is the one that's out there on GitHub. Hopefully everyone's happy with that. And finally, we've got the stash. So I won't delve too much into this today, but say we wanted to do something in Git and we get a complaint. So maybe, and this is a slightly skipping ahead to branches. You won't, okay. You might find sometimes you find that Git complains because it says you've got untracked or unstaged changes that you need to handle. If you want to do this, you can make use of git stash. So if we do git stash and run the command, and then run that again, you can see that what git stash has done is take any local changes we had, plus any stage changes we've had, and sort of folded them away, stashed them away to be used later, and reverted it to a kind of a clean state of whatever the last commit on our branch was. So we might now want to do something else, make some changes, maybe add a different file, do a commit, maybe pull some stuff down from remote. So sometimes this happens if you do some work locally and then try and do a git pull. Sometimes to resolve this, you can actually stash things locally, do what you need to do, and then if we do git stash pop, you'll see that it's push those stuff back out, though we have lost everything we had about staging. So it's just given us all of those changes in that one file. There. So we haven't lost anything. So right, yeah. So linked from the slides. Often I find this is a really nice place to look to represent all of this visually. So what it does is it sets out kind of the different areas we've just been talking about, but also gives you the commands that you can use to move between them. And like I say, Git is a rabbit hole. There's far more than we talk about here, but you've got your workspace. As we said, we can do diffs to the index. We can add files, which will send them to the index. Once we're in the index, we can use commit to add them into our local repository. And anyone want to guess what the commands are going to be from the local repository to the upstream? Hooray, there we go. And to get things back is git fetch or git pull somewhere. Okay. Let me just move that back there. So far, so good. So this is, I think Chris mentioned in his session, some work by Julia Evans. There's also a Julia Evans comic here, which I think is important just to highlight. A lot of people sort of treat Git as this place to look after their work and store it as backups. Really, sort of Git is far more than that, and we can use it to be far more productive and write good software. But it's worth bearing in mind that it isn't kind of this perfect backup system. There are some more or less dangerous areas, and this comment kind of sets out where things are safe, where things are not so safe, and where you should think about committing and pushing before you shut your computer down and go off to do whatever high-risk activity it is. So the question really that we want to address, that's kind of the introduction over, is how this is going to help us working in science and working in scientific software. So the first exercise is to get hold of the code for this project. So you will have seen me do this a moment ago, but if you go to this URL here, you should be able to do this. You can git clone it immediately, but I would encourage you, if you want to actually fork the repository. So if you click on the fork button up here and choose yourself as the owner and the name of the repo, this will be useful as we move through the workshop, because you'll actually be able to use it then to open pull requests back into my code repository, and we'll talk a bit about the process of doing that. So yeah, it'll be useful if you fork it, but if you would prefer to work just from a local clone, that's absolutely fine. And I did put the links to that in the Slack workspace as well. No, so the question was, if you force push something, is there any way to manage the disaster? In short, no. So this is one of the things I think in the previous comment said force pushing is a dangerous action. So force pushing, if people's not come across it, is where you say, often you'll have seen if someone else has committed something to a Git repo and then you try and push, it'll say, no, someone else has put work up there. You can't overwrite what they've done. You've got to pull first. So my first piece of advice would be you can use so my first one would be, so the command to do this is git push force. I would never use that. I would always advise you using this longer command, which is git push force release. And what this is, it will say, if you're pushing up and the only person's work you're overwriting is your own, we're going to assume you know what you're doing and you want to do that, because sometimes you do. Sometimes you do. But if you're going to overwrite someone else's work, it'll actually abort before doing that and say, you're going to overwrite someone else's work, maybe go and check with them first or decide if this is what you really want to do. The other one is, if you have done this and you're in a disaster, you can look at using what's called the Git ref log, which is, yes, here, which kind of is a local log of all the things you've done on your computer. And so somewhere in there, if you can refer the state of the repo before, then that might help you. But if you've never Git pulled and you've overwritten someone else's work, that won't be in your ref log and it will be gone. Joe. Yeah, so there's an extra thing you can do in sort of on GitHub, which is apply rules that say, yeah, and so particularly for main, you can set on a set of rules that say, even if the user really wants to do this, don't let them do it. Okay, so hopefully everyone's got that code now. If we have a quick look around, it's relatively simple. It's a little Python library that implements the pendulum equations. So as we now all know, we're going to put this into a virtual environment before we do anything else with installing. And then this has been sort of nicely packaged, so we can do pip install, and I'm going to use the -e command and then the /. The -e, as a side note, if you've not seen it before, is to do an editable install. So what this is saying is when I install my code, I might come and make some subsequent changes, but Git is going to follow all of these. We don't need to reinstall it every time we make some changes. So that's shorthand for editable, which says do an editable install. Not relevant to this workshop, but might be useful. So that should go away, churn and do some things. And then if we boot into the Python REPL, we should be able to do an no, let me remind myself what it should be called. So it gives us a few little pendulum equations. This isn't important to the course. The idea is that there's a little Python library that will do some basic calculations for us. So get period is going to say, given the length of some pendulum, given a length of some pendulum, calculate the period in seconds for the swing. And indeed, that's what we've done there. So all well and good. Everything is working as we hoped it would. So the first thing I want to talk about is files that are in the repository. So you will have seen in here when you landed, there's a few things already for you. And there's a number of these that are particularly useful when it comes to working with software and sharing your software with others or coming back to use it later on. And the first one of these is what we call the README. So hopefully most people have come across READMEs before. These are some kind of file that sits in the main directory of your repository, and it's designed to be the first entry point to any new users for your code. And it's important because it makes sure that your code is being used properly and is also easy to use. You don't have someone coming back to you saying, oh, what do I need to install to get this to work? Or, oh, I tried to run this, but it didn't work. And there's an easy answer that could have been given to users. So traditionally, this was often just a kind of a plain text file back in the days of yore. Now that almost everything is hosted either on GitHub or GitLab, these tend to be written in Markdown. And so you'll often see them as a readme.md file rather than a just readme or readme.txt. And you can see the nice thing about writing them in Markdown is that GitHub will sort of do this nice rendering for us. So it will give us these sort of titles, these code blocks, and everything else. So there's a few examples of readmes. So here is the really bad example, which is nothing. And so we look at this, we arrive at this, someone says, oh, you can use my code to do X, it's here. And you sort of say, great, well, where do I don't know, where do I sort of look for this? Do I run maybe process models? That sounds like a good starting point, but I don't know, maybe we want, yeah, I don't know. We don't know where to start. So a slightly better example is to have something. Again, this sort of tells us that this is a collection of tools. It tells us who wrote it. There's a paper somewhere. But again, it doesn't really tell us anything about using the code or using the software. A much better example is here. This again gives us that starting point of what the code is, what it does. We can read it and decide, is this useful for me? But it then gives us some information about how we can install it. So with a pip install, it gives us some information about where we can get started in the code if we're coming it the first time. And it gives us a bit of a description about what the code is, how you can get involved with it, and other things. So I won't dwell too much on this because there'll be a discussion in the RSE skills session tomorrow. But the thing to think about is, could you give this to a user and would they be able to take the code just from a URL link and start using the code and doing the basic things with it? So the first exercise would have been to improve this README, but because of time, we've sort of done this already, but we can have a quick look and see that we've got all of this, the information we need to get started. We've got the information for how we can do a simple import and do that first, playing around with a couple of equations to see what's happening. Okay, any questions at that juncture? Yes. The slide mentioned badges. Everyone likes badges, badge collecting. There are no badges here, but if we go to the wonderful FTorch, oh, no, you can see at the top of the repo are some nice badges that tell us what the license is. We don't have to scroll down. We don't have to look elsewhere. There's a nice little thing. There's a little badge that tells us where this has been published. There's a little badge that tells us what Fortran standard we're using. So we can get all of these at a quick glance. I think also maybe we can go to one I prepared earlier, which here's even more. So if we've got workflows on our repository, it will tell us if our tests are passing. It will give us sort of information about the versions of Python we can use, maybe the fact that the code is managed with rough, this sort of thing. Okay. Yes, so this is rendered nicely with Markdown. And yeah, we can talk about adding that, but there's some little Markdown widgets you can add. Okay, super. So the next thing to talk about is licenses. Any code that you put out into the public domain should have a license attached. And there's a few reasons for doing this. It's to protect kind of your ownership of the code. So if you've written this, you've spent a lot of time developing it, you want some way of kind of retaining a link to that code and for you to be acknowledged as the code being something that you put out there. It's also to kind of limit liability. So if you release code with no license attached and someone uses it to do nefarious or other things, they may choose to come after you at a later point. Whereas if you've got a license that clearly states what they do is their responsibility, that's quite useful. And then the last thing is it clarifies what you can do with the code. So you might have particular restrictions you want to put on the code. So maybe you're NVIDIA, you don't want your code being used for Intel to make money. So you put something very, very clearly on there about what it can be used for. On the flip side, you might support the free software revolution. You don't want your code being used by anyone to make any money. It should be free forever. You can attach a license to also enforce this. Again, we'll be talking in more detail about this in the RSE skills session tomorrow. But what I want to particularly discuss here is actually how you can add a license to your code. Like I say, we'll talk about choosing particular types of licenses tomorrow. But in GitHub, you'll find that there's a handy set of utilities that will do this. So if we go to, oh, this is going to stretch me. Here, the button, right, yes. So on the GitHub interface, you'll find there's a little button here that will do add file. If we click on that and do create new file, we've discussed that the default location for the license in a code base is at the top level and is a file with license as all the capital letters. So if we type that in there, you'll see that this handy little button pops up here saying choose a license template. And yes, we do want to discard those changes for now. And this will actually give us a whole host of different open source licenses, sort of that are quite popular that we can choose from. For this particular code base, I'm going to go with the GNU Lesser Public License version 3. And if we click on that, you'll see it gives you a little bit of information about that. You can read it later, pick one that you're happy with. And then we click review and submit. And you'll see that it's actually generated automatically for us this kind of standard licensing. It will have put all the information we need in there. We can just immediately commit that into the main branch using the GitHub UI. So adding a license to your code, as long as you know which one you want, is as easy as that. And I would encourage you, if you've got any code out there at the moment that's unlicensed, to go and do so. Yes, there's a question. No, and this is one of the big problems, discussions. Well, yeah, maybe we'll have to edit that. No one knows. If you ask OpenAI, they will probably give you one answer. But whether that was built into the models for training, who can say? Because the models that they're using, particularly the training code and the training data, isn't open source. And there are instances, I think, with the early Copilot where people were saying there were private repositories or unlicensed repositories where Copilot knew a lot about predicting the code in them that it perhaps one would imagine shouldn't do if it hadn't seen that before. You can do it, but it's often easier to go from permissive to non-permissive. So if you had a code that was licensed under, say, MIT, and you said, this is licensed under MIT, you can do anything, don't sue me. You can then relicense that at some point to say the code from here on out is now GPL, and any subsequent changes can't be used for anything unless it's also GPL. But one of the key bits of the GPL license is to say anything from here on forward must be GPL. It's sort of a virulent, whatever the word is. And so if you want to change from GPL to something more permissive, that's get a lawyer. Okay. So yeah, adding a license is as easy as that. However, because we have changed some things on GitHub on our remote, we do need to make sure we get those changes back into our local repo so we can do a git pull, which will do a bunch of things. We can see we've added a license file, lots of pluses, away we go. And if we do an ls, the license file has appeared. Wonderful. So the next one, as promised, is the git ignore file. So is anyone not familiar with git ignore? Super. One person means it's worth doing. So I think indeed, as we saw just now, when we did that ls, so I move this up, as well as the files we expected to have, we've also got this .egg info in there. If I do a slightly longer, we might have even more things. So when our computer does stuff behind the scenes as we're working, it ends up putting a bunch of these sort of additional files. Maybe you've seen PyCache or __ something, or the dreaded .dsstore. These are all things that that sit in there, useful for working on our computer, but we don't want them in our general code base. We don't want them being committed up to our GitHub repo. But if we're sort of being slightly uncareful, or we do, say, git status, so even now, if we run git status, we can see that we've got these PyCache and egg info files being picked up. And sort of, you can imagine as we continue working, this is only going to build up more and more and more, distracting us from what we're trying to do. So the idea of the .git ignore file is that it's this sort of text list of text patterns that will be matched when we run any git commands, and anything that matches those files won't be touched by git. It'll just be as the name suggests, ignored. So it sort of makes it easier for us to filter through what's important. So like I say, anything that's junk that shouldn't be in there, .ds stores. It's also good to add things like your build files, so .o files from compile. Yeah, and indeed that was the other one. Is large .cdf files, or before I knew better, when I was writing my thesis, I used to commit the PDF render of my thesis, which meant that when I tried to git clone this, it would sort of be sat there for hours and hours as it tried to clone every version of that, however many page PDF. Maybe fewer people have seen, but what might be particularly useful here is, as well as licenses, GitHub gives you a handy dandy little utility to do exactly the same thing here. So if we something, so if we do git ignore, again, it's recognized this is kind of a default type of file name and says, let's choose something. Here we've got Python code, and you can see here, as well as the things that we might have thought of, it's given us a whole bunch of other things. So where were we? We've got that egg info. We're going to get rid of that. I imagine somewhere in here will be PyCache, PyPackages. Maybe I won't post it. Anyway, somewhere in here will be the PyCache. It'll ignore that as well. And you saw, like, as I say, you saw that there's a whole bunch of other languages you can do this for. And so we can commit those. Again, commit those onto the main branch, and you'll see this has created something. So now if I do git pull to get those latest changes in and run again our git status command, you'll see that all of that detritus that was clogging up the git status has now vanished and gone away. The other thing that's worth saying here is that now any files that fall under that won't be picked up. If there's maybe a file that you do want there, suppose you've got one .cdf file that contains constants that need to be read in order to run your code appropriately, you can still add that with a git add command, but you have to explicitly specify the path of that file. So it's not a ubiquitous, you can nevermore add a .cdf. It's just going to remove anything else from kind of clogging up your vision. And one final note in there, if you've got confidential information in your repository somewhere, please don't handle this using a git ignore. You should be doing something more sensible with this, not just relying on a git ignore file. Okay, so again, sorry, I should have said these are labeled as exercises to do the same thing on the repository that you've got. Hopefully you've been following along and pulled these things down. Any questions there? Yes, you can protect it with a GPG key, might be one option. So if you've run encryption on it and that encryption produces a text file that only you have the key to encrypt, that nominally is, at least until I guess we crack quantum computing or whatever, that's relatively safe to commit backup. And it's then a part of the process. You would add it maybe to your README. The part of the process is to, after you've cloned that repository, to unencrypt any of those relevant files and as such. Or yeah, Omar? And I was also going to say, on that sort of, if you are using sensitive info, an API key or something else, don't pull it in, like don't keep your API in your Git repo, put your API key in a .config or something else so that it never has the risk of being pulled in to be committed. And Chris had a point as well. Yeah, so we won't touch today, but there are things called pre-commit hooks, which sort of say whenever I run git commit, it will do some stuff before it actually creates that commit. And this, often people use these for maybe formatting. So you can imagine, we were talking this morning about nicely formatted code. You can run one that says, if this code hasn't been nicely formatted, send it back. You could have one like Chris says that scans over and says, you probably don't want to put this in here, maybe fix it before you do. Super. So we're now going to move on to talk about Git workflows a little bit, which is kind of a bit I'm particularly interested in here, because this is how you can actually be using Git to hopefully be doing more productive or better work. So the first thing to talk about is issues. So these are on both GitHub and GitLab, and they can be really useful for kind of organizing your work. So it's a nice way, if you're working on multiple things at once, you can kind of divide your divide tasks up. It's also if you have problems that arise with your code, but maybe you don't want to fix immediately, but you want to make sure they're captured somewhere, it's useful for doing that. And it's also, as you're kind of developing a new piece of code, you can use it for kind of tracking the work you're doing. So I think, oh, why are you sad? I think if we open an example here, you can see the sort of things we've got. So there's a few different things. More recently, sort of someone's logged that we have a problem. Maybe people have raised an issue that we've spotted that there's a problem with the code when we try and run a particular configuration. So there's an issue raised that says we should do something about this. We're not going to fix it immediately, but it's now logged there. I don't have to keep it in my mind or in some text document somewhere. There's also, we can use things for kind of tracking code development. So I'm thinking here, this is adding a new feature to the code. So we want to add a scalar class. This can be tracked, and you can see that there's then sort of some discussion and linked things underneath as we work towards completing these different tasks. So it's a good way of getting things out of your head into organization, but tied alongside your code. So the exercise we're going to look at is to say, yeah, that's a very good question. So you can put links to files. You can also put links to specific bits of files. So maybe we'll do this in the example. Yeah, indeed. And this is not just with issues, you can do this ubiquitously on GitHub, wherever you're typing things in. So there's an issue here that we've got some pendulum equations, but what we sort of notably have missing from this is an equation to calculate the energy or do the inverse calculation of getting the pendulum length from a given period. So it'd be nice to do that. And we should open some issues for that on the repository. If you're working on your own code, usually you can open issues on that repository. If you've created a fork, often by default, it will send you to the repository you forked on to open that issue. So what I would suggest people do for this is open the issue on the repository that you forked from and add something to say that. So I will do one for the energy, and perhaps other people can open one for pendulum length. And so it might be useful to say the way we do this is from this issues tab at the top, and then we click create new issue, which gives us the option of a title. So and the question you had, sorry, was, can I link lines of code? So if we go into a file on GitHub, and yes, there we go. So yeah, we would say this is somehow the pendulum energy is related to the maximum height. So you'll see that you get the option when you click in the gutter to copy line or copy permalink and do various other things. If you click the copy permalink and then come back here and paste that, if we look at the preview, you'll see that GitHub nicely sorts all that out and puts that in for us there. It's slightly janky, so you can see it's generated this URL at the top. It can be slightly janky, but there is a way to get multiple lines. So if we do dash line 39, you'll see that it is possible to highlight multiple lines. So if we replace that, and what did I say that was? That's maximum height. Yep. An excellent question. So you can see at the moment, this is giving us the URL has main. And so that will change if someone changes the code. What you could do is go to a specific commit here and open up the file so that you get, if we do view file, you'll see that now the URL has that commit hash. And so it will give us a permalink to the code at that commit hash in the repository. So if you wanted to be belt and braces about it, that would be one way to do it. Yeah, so I think we should be able to, you said it would be related to max height. Yeah. So I'll put that in there and we do line 29. So there we go, we've copied that. So we can now, knowing even better, add that into the issue there. And if we quick create, there we go, we've got the issue. A few useful things we can do is if we want have multiple people working collaboratively on a project, we can assign people to say who's going to take on this task. We also have a number of labels that can be useful when we're organizing things. So looking at these, any suggestions for what we might label this? Yeah, it's a new feature or requesting a new feature. Super. So maybe, here we go. Thank you, Chris. Chris has opened. I guess one thing we can't stop people doing on GitHub is posting. But yeah, here we go. There's a few things we can talk about around this. I've lost my slides. Is what things are good on issues. So if you're opening an issue, don't just put, I want this, please do it. If you can add some information about what else should be in there. So maybe what might have been nice to see on here. Does anyone have suggestions? Yeah. Right, yes, sorry. So there's no requirements file because this has been packaged, but the PyProject on means if you run if you run pip install -- editable dot, that should install all the requirements you need for you. Yeah. You can close issues. I've never attempted to. So normally we're probably so yes, if we've got people opening issues that we're particularly maybe not going to deal with, then we can close with comment. And you'll see there's a few options here as well. We can say exactly why we're closing this. In terms of deleting, I've never actually looked, but unless you're talking sort of, I don't know, PyTorch size of repository, probably no one's going to be spamming your code with that much junk. Okay. Yeah, there might be, yeah. Anyway, somewhat off topic. So what I was going to say is it's worth giving a little bit of thought into here. So rather than just saying add an equation for pendulum energy, if we'd maybe given some citation or some indication of what the equation for pendulum energy is that we're wanting to implement, that would be useful. Though it is nice, we've given sort of an indication of where in the code we might want to put this. So the next thing to talk about is Git branches. So who has used Git branches before? Okay, about 2/3, that's not bad. So hopefully you don't need convincing benefits for this. If we've done lots of linear commits as we have done so far, our code looks like this. But as someone said, if someone's modifying the same files as us, we might run into sort of merge conflicts or the danger of overwriting people's work or getting confused. Maybe they edit something that we also want to edit. And so the solution of doing this is to use Git branches. So there's a few different commands that we'll run through here. But what I sort of want to highlight for you is that the real advantage of using Git branches is when we want to manage our workflow, particularly in terms of kind of this idea of project organization. And so if we have maybe those two different issues we want to work on, adding an equation for pendulum energy, adding an equation for pendulum length from period, if we create two separate branches to work on these, we can kind of work on these concurrently. If you sort of think of this as time going along the x-axis, you can sort of work on one, hop off to work on something else. In the meantime, hop back to work on this, all without the danger of overwriting things one another. The nice thing is where this sort of ties in with issues, and we'll look at subsequently pull requests, is that kind of you can tie different branches to different issues, different branches or different pull requests to different issues, and it'll help a lot with your project organization. So yeah, the key commands here are git branch, and then you give it a name for your branch, and this will tell Git to do the work to create this kind of fork in the path. When you do that, nothing will have changed in your repository itself. To actually move on to this other branch, you need to use checkout, which is telling us to move from where we're currently working onto the other branch. And then when we come to the end of doing things and we want to bring code back together like this, we have the git merge command. Though, as we'll see shortly, there are some very nice utilities within GitHub itself to help us manage this in a better manner. So in the example here, I'm going to start by working on, so give me a moment. So I'm going to start by working on the energy equation. So if I do, and we give our branches sensible titles so that we can find them later. And also maybe worth noticing is there's the git branch command. If we don't give it anything, will just give us a list of all the branches we've got on our local system. So we can see here's the one we created at the start. Here's the one that we're currently working on with a nice little star. And here's the one we've just created. So if you ever sort of forget you're working on something and you sort of think, oh, I added a branch to do something, git branch will give you a list of what things are on your local repo. So git check out, and then the name of the branch, you'll see has switched us to that branch, and has also brought any of those kind of changes that we had that we'd made to myfile.txt. because we hadn't added or committed them on the other branch, it's actually pulled them across to this branch. So maybe you're working on your repo on main, you do a bunch of code development and you realize, oh no, I should have done this and it should be in a separate branch and I wanted to do separate development. If you run the git checkout branch command, it will take all of that in progress work over without doing anything drastic. So you can sort of change it there. You don't have to worry about stashing or copying and pasting and all of this stuff. Okay. So it's where are we? For those of us who learn in different ways, and I guess even older reference than Futurama is tubular bells. So there's a really nice video that kind of demonstrates the idea of using branches plus a whole host of other things that I can maybe get to play. I'm not going to play the whole thing to dwell on it too long. But so I'd very much encourage you to go back in your own time to watch the rest of that and all of Dylan Beatty's other videos. But the idea is sort of it shows you maybe more auditory example of how you can move different commits with different instruments onto different branches, put things together, commit, etc. Okay, so this exercise we've sort of been working on by creating branches in there. So the suggestion I have is to create a branch and add some stuff in. So as an exercise, I will give you maybe 5 minutes. If some people want to take the energy equation, some people want to take the pendulum length equation, Google that, find what it is, and implement that into the code on a branch, and then add and commit your changes. Presentation. Well spotted. I have indeed. If you fancy opening an issue on the repository to suggest changing that, uh, for yeah. So I've added some code. I'm going to add the file, and as I mentioned, there is the shorthand you had before. So if you've got some files that have been modified, we can do git add -u, which will move any files that we've sort of been tracking through our Git process. It will add those into the staging area without having to specify them explicitly. So that can be useful sometimes if you've got maybe 6 or 7 files that you know all want to be in one commit. It'll save you writing them out all one by one without running the risk of adding sort of everything with a git add -a. And so if people got something that's gone up, getting this release, cool. So don't worry too much. We'll move on in the interest of time. So there's an aside here, and we did just talk about, I get a bit with legit commit messages and why we don't want too much pollution. So yeah, I would like to say as a slight aside to mention git commit messages. So when you run a git commit, it can be tempting to just do this when it feels right. But please try and avoid situations that look like this. Because the idea of Git, as we said at the start, is to manage, sort of compartmentalize things into manageable chunks so we can go back through the history of our project, maybe go to things we did before, make some changes, revert some changes, pull some changes to another location. If something looks like this, we don't have much chance of doing this. So I will not name the individual here, but please don't be like this individual. A slightly better example here is to provide, as I say, usable commit messages. So try and summarize what you're doing with each commit. And when you're constructing the commit, you don't have to add all of the files that have been changed. If you've changed maybe 10 or 12 files, if it makes sense to break that up into a smaller chunk, git add the files that make sense, commit those, then add the next set of files as might seem appropriate. And so you can see here, there's something that says we removed an unused variable. If we're working on our code at a later date and we decide, this is true story, you decide that this variable that was unused that you took out, you now want to make use of it again, you can go straight back to this, sort of, you can do a search in GitHub, go straight back to this commit and find all the things that you need to do to specifically undo that change, which is going to be a lot faster than trying to add that in as a new variable, almost working from scratch. If you didn't have Git, or trying to search through this commit by commit to find out where that happened. Yes. Yes. and we will look at that very, very shortly. So the last thing I was going to say is commit messages are slightly to taste. Some people will have differing opinions on this, but the one thing I would say particularly to take away is write sensible messages in there. Don't just spam the keyboard. Okay, so the next thing we're going to talk about is merge or pull requests. So I said that there's some command line utilities in Git to sort of bring branches of code back together. There's much nicer ways of doing this in GitHub or GitLab that also give us a lot more benefits around kind of the development process. And as people have hinted at already, by doing them using this, you can link them up to different issues, different bits of the code that you've been working on to tie this all into kind of a project management sort of system. I had my code here. What I'm going to do is do a git push. And as we said before, I'm going to send this up to the origin. But because this doesn't exist on the, because this is a local branch here, I'm going to do energy equation. And you'll find that now, if we go to the repo, yes. So the origin, there's git push, and then there's two things that come after. The first one is the remote, and the second one is the branch name. So origin is what the place that you cloned something from will be called, and it's kind of the default name. But if you had a situation where maybe you forked someone's code and you want to work on both their version of the code, but also your fork, you can have multiple remotes in there. Or an example of this is if I'm managing some code and someone opens a pull request, I might want to be able to modify their code as well. So I can kind of work on those two separate repositories just from one location. But most of the time, you'll just be working with origin. It's just worth being aware of what it is rather than it just being a magic word. So if we pushed up to GitHub, you'll see that at the top of here, there'll be a little thing that says, oh, you've added some code to a new branch. Probably you're doing this because you want to bring it into the main code. How about you open a pull request? So if we click on that, we can add this here, and it'll give you some kind of title. You can edit that as appropriate, and then you can add some things in to talk about what you're doing. So good to say what we're doing with this pull request. However, as someone else has pointed out, we can also say link to particular GitHub issues. So I say this will close. And if we use the hashtag sort of number marker, you'll see that there's a pop-up that comes along and gives us sort of recent things that are on our repository that we can choose to link. This is going to close the issue that I opened for adding an equation for pendulum energy. So if we do that and then create that pull request, you'll see that this gives us this kind of link over to that issue. So these are now tracked. If someone else goes to that issue and thinks, oh, I'm also having this problem, is anyone doing anything? We can see that it is being worked on. The other nice thing that we'll see in a moment is that GitHub has these keywords. So the keyword in this instance is close. And what this is going to do is GitHub has sort of realized that the code we're putting in here will fix the problem we raised in that issue. So when we bring this back into the code, actually, let's close that issue down, move it to the completed pile. And so we'll do all of that, keep things tidy without us having to worry so much about it. And you can see it's done that by popping up just down here in this development space. So if you forgot to do that at the time, you can always add more links there. Okay. So where have we gone? So yeah, these, like I say, these are useful to do this on GitHub rather than doing it just in the command line, because underneath all of this, sort of, you can see that I can write some code, I can write more stuff down here. So this is kind of a space where you can have discussions about code that's going on. This is a space, sort of anyone else who's coming to look at this repository could take a look at this. So if I wanted to work with, say, my supervisor, I say, oh, I've been doing some stuff, but I'm a little bit stuck. Could you take a look at what I've done so far? A particularly nice thing here is that it gives you sort of a summary of the code that's been changed. So you can see here the code that I've added. So someone could come along and look at this. And the other thing to say is that you can open these as soon as you've pushed a single commit up to your remote repository. You don't have to wait till everything is in working order. You can kind of, you can use these, they'll work from a single commit. But if I then, let's say, say I want to change something, I realize that it would be nice to match the formatting here by having square brackets around my units. So you'll see if I do a subsequent push to that branch, this commit will now appear on that pull request. And so it kind of keeps live track of any progress that's going on. And so maybe if you discuss something, you can then add another commit based on that discussion. And so it's useful as kind of a collaborative tool discussing with others. People can write comments down here. And if you're doing it, in this manner, it's useful for then having these discussions, facilitating this. We can have this really nice demonstration of anything that we've changed. We don't have to kind of try emailing text files of code or taking a laptop and showing someone some code or stuff. Okay. So some good things to have in there. So a description of what you've done. Don't just open an empty pull request assuming whoever's going to look at it knows what's happened. If there's quite a lot of code in there, which there might be within sort of scientific stuff, try and provide some kind of summary, some kind of references. If you've got any points that you want to be particularly aware of, any particular gotchas or things that might be hard to understand, it's useful to include that. And then the last thing, sort of thinking about just project management, would be it's possible in GitHub to add checkboxes. Checkboxes to these. So if you've kind of got a much longer task that you're trying to work through, it might be useful for your organization to be able to have things and tick these off as you go through working through different commits. Yep. That's a good question. So create a merge commit. We've had commits on two separate branches. If we do a merge commit, what Git will do is kind of tie these branches together so that the code is brought in. It will create a commit that says, at this point, I tied these two branches together, but in the history, things kind of still sit separately. If you do squash and merge, what Git will do is say, you've done a load of commits on this branch, but we're going to assume the order of these or the different messages aren't important. We're going to squash them all down into one single commit, and then we're going to dump that into the code. Yeah, so what GitHub will do is it will kind of, so I think if we squash and merge, it will, oh, dangerous. So what it will do is it will actually give you an extended description where it does keep your extended messages, which is a nice reason to do it through GitHub. And you can edit that message, but that is just text. It's kind of the context of what code changed within those individual commits is lost. And this can be nice for some things, can be nasty for other things. There was an example in FTorch we had recently where, because kind of a lot of code had been squashed, there'd been a bug introduced somewhere in all of that code, but actually tracking down what it was more challenging. So the last one is rebase and merge. So what rebase will do is it will say, rather than kind of tying things together, so there's this kind of overlapping intermeshing history of two branches, I'm going to take all of the commits on the branch that you've been working on, sort of pick them up, stack them on top of the main branch, and so you preserve this kind of linear history. Sometimes you'll see that some of these are not possible. So I think squash, in general, squash is possible, but sometimes merging, and I think rebase can be the most finicky one, is by doing this, you might have overwrites of other people's work. And so it might say you can't do this. Yes, you can pick your champion, and whoever prefers the other two can pick their champion, and we'll have a big fight about it afterwards. No, it's a matter for debate, and it's also sometimes situation dependent as well. There's never one best solution. So in the interest of time, I will try and push forward because I do want to cover the last bit, which is code reviews. So code review is when we go through and look at other people's code, make some comments on it, and sort of talk about what it is. I think a lot of people are very reticent about this, but I want to emphasize here that this is not kind of a process just for real software. It's really, really beneficial for any software, including scientific software, and it's not a chance for you to feel bad. So there will be things that are spotted that are wrong, but rather try and view these as a chance to kind of reflect on what you've written, learn from other people. So this is sort of, hopefully at the summer school, you'll be learning about new tools, new techniques. If someone looks at your code and says, oh, I see you've done this with a mutable list. Did you know that mutable lists are bad? There you go, you learned something that will improve your code. It's also kind of good just against guarding against laziness. Yes. Yeah, so it's good practice to delete the branch, and we'll see this in a second. So when we're doing code reviews, as we say, it's always good to be nice. So remember that when you're reviewing someone's code, the other person at the other end is a person. If you're going to suggest they do some changes, unless it's something that's really obvious, like, oh, you spelt this wrong, try and give some justification for why you're suggesting they change things. Again, it's kind of good for a good chance for people to learn. And then finally, something that's just my opinion, but if you see something that's good code or you've learned something, point this out as well. Otherwise, the code review process can just be a series of this is wrong, this is wrong, this is wrong, this is wrong, this is wrong. If there's something in there where you can say, oh, this is really nice, thanks for highlighting this, that's a nice thing to do. The other thing is don't impose preferences. So don't kind of be nitpicky. If you want American English and someone's used English, unless there's clear guidance about doing that, don't get overly picky or sort of minor formatting issues. So the very last exercise is to do code review. So we're going to assume that my code here is perfect, and I'm going to merge it in. And as Addy said a second ago, after doing that, it's a good idea to delete the branch just so that things are kept clean. But what we can do is perfectly, some people have opened some pull requests, and we can have a look here. So, all right, that's a separate one. Unfortunately, everyone went for energy. So if I go into here and I look at the code, there's a few things I can comment on. So the first thing I would perhaps say in here is, and so if we look at some code and we want to review it, If we pull open the box here, the space to type comments and write a review. We can also, through the power of GitHub, leave comments on specific lines, or at least we should be able to. Yeah, here, leave comments on specific. So one of the comments I would maybe include here is to say, sort of say this stuff is coming off topic. So the user here, thank you very much for opening it. But this is specifically adding an energy equation. We don't want code that's relating to other things. And this is the reason we would do this is you can imagine if we squash this or move this in, we've got some feature that says add energy equation, but suddenly we've got code that doesn't pertain to this at all. If we then have a bug somewhere trying to track this down and it going to a commit that says add energy equation can be somewhat of a misnomer. Yep. So if it's an open repository, they're viewable by everyone. And I can do things like, so we go through. So I can finish, and so I can say there's a few options here. I can either leave a comment, which is kind of neutral. I can approve the pull request is if everything looks great, and I say, yep, please, I want this code. Or I can do some request changes. And so you'll see if I submit that review, it'll go and it'll leave a bit of feedback. It'll point to where we've done things. And then the user can come along and kind of, if they've fixed this, add some more commits. And as I said before, if the user adds more commits onto this pull request, they'll just stack up here. So you can kind of do the work, resolve the conversations as we go along, et cetera, et cetera. So I'm conscious this is getting towards the end. So as I say, sort of Git's not just a series of backups for your files. It's an entire kind of project management system for code. Things we've looked at today are improving the repositories you have on Git with certain files, making use of branches to kind of manage the development of our codes, and then making use of the corresponding functions and features of GitHub to kind of track and tag all of these in a graphical space. If you want to get more, there's a few links here. I should say the Git documentation itself is notoriously impenetrable. So I would generally suggest looking elsewhere. I think GitHub actually has some quite good documentation now. There's this pro Git book. If something's gone really, really, really wrong, a nice website is Oh Shit Git, which will give you a bunch of, I think, maybe relating to what you're asking, Brigitte, of if you've suddenly done something very bad, there's a few kind of key situations here, and it can hopefully get you out of a tight spot in some of those. Yeah. So with that, I think that's finished. I realized we did go a bit fast at the end there. So if anyone has subsequent questions, I will be hanging around or here for the rest of the week. So please do discuss more. And I have been asked to say that you need to be back in front of Churchill by 6 p.m. before the bus to go to dinner. Otherwise, thank you very much.